Welcome to solverfy.
Okay, we have three reactions here. The first of which is this dichlorobutane reacting with sodium amide. Two equivalents of sodium amide. And essentially what each equivalent of sodium amide is going to do is remove chlorine and install a double bond. So if you have two equivalents, it's going to remove both of these chlorines and then install two double bonds or two pi bonds, resulting in a triple bond. And it's going to do this selectively at the less substituted carbon, which means that we're going to get an external alkene, or we're going to get a triple bond on the end of the molecule. 1 carbon, 2 carbon, 3 carbon, 4 carbon. That would be our product. Okay, next, okay, that's A. Next, we have this alkene, and we're reacting it with mercury acetate and water and THF, and then hitting it with sodium borohydride. And this is the oxymercuration demercuration reaction. It installs a hydroxyl. It does so in Markovnikov fashion, right? And it will also add anti. That is, it's going to, well, it technically adds a hydrogen and an OH, but the hydrogen and the OH will end up anti to each other. Okay. Well, what that means is that there's two possible locations for this hydroxyl to add if it adds in Markovnikov fashion. The only real discriminating factor is the degree of substitution of the carbon to which it will add, but this would be a secondary carbon. This is also a secondary carbon, so theoretically it can add to either side. Right? So we could end up with, say, something like this. We get an OH and our hydrogen adding anti to each other, where the OH adds to the left, or where the OH adds to the right, and the hydrogen adds anti. Now, in this particular example, this hydrogen is not a stereocenter, and neither is this one. Right. So, in fact, the fact that it's adding anti with its hydrogen is sort of not entirely necessary to spell out. And there's something else that's interesting about this molecule. You may have noticed that I arbitrarily chose to draw this hydroxyl pointing up and the hydrogen pointing down. We also would have gotten this molecule. Right, the hydroxyl pointing down and the hydrogen pointing up. And as I said, the stereochemistry in the product of this hydrogen doesn't matter. Neither does this one. Neither does this one. And that in addition to the version where hydroxyl adds to the right and points up, we get the version where hydroxyl adds to the right and points down. And what we're going to find out is that these two are the same molecule, and these two are the same molecule. You just flop them on their face. So what we're going to get is a mixture, 50% of these two and 50% of those two, or you could also represent that as simply drawing one enantiomer and the other enantiomer, and say that you get a racemic mixture. Okay, so that's basically the final answer. Right, so the fact that they add anti to each other didn't really matter because the two hydrogens that you would end up on the carbon to the right. And the stereoselectivity ended up just giving us two paths to the same set of molecules. Sorry, the regioselectivity gave us two paths to the same molecule. Okay, final problem. we are reacting this with H2, palladium on carbon, in ethanol. Okay, so we should recognize this particular, well, the H2 is going to be essentially a reducing agent when given in the presence of some sort of metal catalyst. That's what the palladium on carbon is. And so what this is going to do is reduce our double bonds and triple bonds, including our nitrile, to single bonds. Okay, so we can simply redraw this molecule, but everywhere we have a double bond or a triple bond, replace it with a single bond. I'm going to draw it down here so there's more room. Okay, and now we have a triple bond between carbon and nitrogen, but that's going to be instead a single bond. I'm going to illustrate that single bond is going to be this single bond, and that this will have then a nitrogen at the end of it. And the one thing that you have to remember to do is that since you can't just have carbon singly bound to nitrogen with nothing on it, is add 2 hydrogens to your nitrogen. So it actually turns it into an amine. And there you are.